In this video, I will explore the graph of a basic exponential function and a couple of other graphs that result from transformations of that graph. So we have the function f of x equals 3 to the x, and we want to complete the table for the function, draw the graph of the function, and state the domain, range, key point, asymptotes, and if the graph is increasing or decreasing. To find function values, I can plug in -2 to the function to get 3 to the -2, or 1 over 3 squared, which is 1 over 9. 3 to the -1 is 1 divided by 3 to the 1, or 1 over 3. 3 to the 0 is 1. 3 to the 1 is 3. And 3 squared is 9. Plotting these points, -2, 1.9 is -2.1 roughly. -1, 1/3 is -1.3. 0, 1, 1, 3, and 2, 9. And then I'm going to draw the graph through these points. Note that the graph goes very, very close to the x-axis but does not touch the x-axis because 3 to some number will never be 0, right? 3 to the x is greater than 0 for all x. And so this line y equals 0, that is the x-axis, is a horizontal asymptote of the graph of this function. So we say y equals 0 is a horizontal asymptote. The domain of this function, there are no restrictions on the values that I can replace x with, so the domain is all real numbers or -infinity to infinity. The range, as we just discussed, cannot be 0. It will never be a negative value. So the range is everything from 0 up to positive infinity or 0 to infinity. A key point on the graph of this function is the y-intercept, which is 0, 1. And the graph is an increasing function. Now let's look at the graph of f of x equals 3 to the -x. If we replace x with -2, notice that we would get 3 to the opposite of -2, or 3 squared, which is 9. 3 to the opposite of -1 is 3 to the 1, or 3. 3 to the 0 is 1. Recall that the opposite of 0 is still 0. 3 to the opposite of 1 is 1/3. And 3 to the opposite of 2 is 1 over 3 squared, or 1 over 9. So this time I'll plot the points to get -2, 9. -1, 3, 0, 1, 1, 1/3, and 2, roughly 0.1. Now we'll draw the graph through these points. Notice that the graph is still asymptotic to the x-axis. That is, the line y equals 0 is a horizontal asymptote. This time the graph is a decreasing function because the graph is going down from left to right. The key point is still the y-intercept of 0, 1. My domain is all real numbers, so -infinity to infinity. The range is still from 0 up to infinity with a parentheses at 0. But how does this graph relate to the previous graph? Notice that this graph is the previous graph, except there's a negative on the x. So this is an inside change, that is a change to the x, and this causes a reflection across the y-axis. So this graph of 3 to the -x is a reflection of 3 to the x across the y-axis. Now we have a function f of x equals the opposite of 3 to the x minus 2. We can use transformations to know what the result should be. That is, we have this interchange of subtracting 2, which means that it's going to shift that basic graph right 2 units. We also have a negative out in front, and that's going to reflect the graph across the x-axis. We'll see that take place whenever we substitute points. If we plug in 0, we would get the opposite of 3 to the 0 minus 2, which is the opposite of 3 to the negative 2, which is negative 1/9. When we plug in 1, we get negative 3 to the 1 minus 2, which is negative 3 to the negative 1, or negative 1/3. Plugging in 2, negative 3 to the 2 minus 2 is negative 3 to the 0, or negative 1. Plugging in 3, negative 3 to the 3 minus 2 is negative 3 to the 1, or negative 3. And then we plug in 4 to get negative 3 to the 4 minus 2, which is negative 3 squared, or negative 9. So plotting these points, we have 0, negative 1/9, 1, negative 1/3, 2, negative 1, 3, negative 3, and 4, negative 9. So we can connect the points to get the graph. And so notice that we can see the shifting right of the basic function and also how the graph has reflected across the x-axis. The domain and range change a little bit, not the domain. The domain is still all real numbers, negative infinity to infinity. The range, this time the graph is below the x-axis, so it would be from negative infinity to 0, but not including 0. This line y equals 0 is the horizontal asymptote. The key point now is this y-intercept, which is 0, negative 1/9. And the graph is decreasing in this particular case. And how does the graph relate to the original graph? It is that graph shifted right 2 units and reflected across the x-axis.